This is Module 1, Lesson 9, titled Tables of Equivalent Ratios. The goals of this lesson are: I can describe what a ratio table is, I can complete a ratio table, and I can use a ratio table to draw conclusions from a problem involving a ratio. Again, pause the video at any time, rewatch parts or rewatch the video as many times as you need, and make sure you take good notes as you watch. Let's go to example number 1. To make paper mache, the art teacher mixes water and flour. For every 2 cups of water, she needs to mix 3 cups of flour to make the paste. Find the equivalent ratios for the ratio relationship 2 cups of water to 3 cups of flour. Represent the equivalent ratios in the table below. So we're going to be creating a tool called a ratio table. It's a very popular tool with students. What a ratio table is a table of ratios that are equivalent to one another. They're equal to one another. We're going to start by using the ratio 2 to 3 because they're mixing 2 cups of water for every 3 cups of flour. So I'm going to start by putting 2 to 3. I want to create equal ratios in order to get larger amounts but still have the same consistency of glue. So another ratio that I could do is 4 to 6. 4 to 6 equals 2 to 3. If I remember some of the other tools that I've used before, like a tape diagram, if I have water to flour, the original ratio was 2 to 3. If each of those pieces were worth 1, we'd have 2 to 3. However, what if each of those was worth 2? Now we would have 4 cups of water mixed with 6 cups of flour. What if we have each of those pieces worth 3? That would give us a ratio of 6 to 9. Another one would be 8 to 12, if each of those pieces were worth 4. And another one would be 10 to 15, if each of those were worth 5. We could also check ourselves with that equivalent ratio tool that we've used before. 2 to 3, I'm going to pick another one. I'm going to choose 10 to 15, the one at the end. Remember, ratios are equivalent if we multiply them by the same amount to get the second ratio, and we do there. So that tells us those are equivalent. We have a ratio table, a table full of equivalent ratios. Now, what I want you to notice, there's some patterns that are going on. If we start with that original ratio 2 to 3, we could multiply by 2 and get the next ratio. We could multiply that original ratio 2 to 3 by 3 to get the next ratio. By 4 and by 5. And if we wanted to, we could keep on going. But there's a multiplicative pattern involving ratio tables. But you got to remember to multiply the first original ratio by that same C value. There's also an additive pattern between them. Notice here we add 2. We add 2 from there, 2 to there, and 2 to there. Every time we're adding 2. Since the second term was a 3, we're adding a 3 every time. So you can use these patterns to figure out equivalent ratios to put in a ratio table.